Welcome to UniAsia. This is the presentation about the flat roofing system for UniAsia building. Roof system provides shelter for the interior spaces of the buildings. As part of an external envelope for a building, roof must be technically good and perform aesthetically satisfactory. There are two main flat roofs constructed at the top of two attached towers. The highest level flat roof, at the 23rd floor, is used to allocate the water tanks both for firefighting and domestic purposes, cooling towers and chill plant room for air conditioning system in the building, and lift motor room. There are aluminium lumbres walls constructed around the perimeter of the flat roof to hide all of the services stated above from sight. The flat roof is also covered by cross aluminium lattice beams. The other flat roof on the top of the second tower, at the 6th floor, was initially designed for rooftop garden, but it is currently unused and left vacant. The flat roof construction for the UniAsia building is made of various layers that consist of the concrete pavers layer, the roofing membrane, and the reinforced concrete structural deck. All these components are combined together to be a roof system that protect the building interior, its content and its occupants from the weather. The 170 mm thick reinforced concrete structural deck supports the dead and live loads from above and transfers them to the pre-stressed beams. This layer is constructed on top of the beam by using poured-in-place method with wood formwork. Rapid hardening is applied in the construction. The minor slope is formed in this layer for draining the roof and preventing the roof ponded after rain. The roofing membrane is the indispensable weatherproofing component of the roof system. Alternate layers of felts and bitumen form a flexible roof cover with sufficient strength to resist normal expansion and contraction forces. This built-up roofing membrane is embedded at the top of the reinforced concrete floor slab after 21 days, since the construction of the floor slab is finished as a dry-up period for the concrete. The bitumen acts as the waterproofing agent, and thus the most important membrane element. Meanwhile, the felts stabilize and reinforce the membrane. The felt strands form a matrix that restrains the bitumen from flowing in the hot weather, and also help the mortar apply the bitumen uniformly. The coated base sheets of felts are mopped to the concrete slab with bitumen. The top layer of the roof is the concrete pavers, filled with bitumen between the gaps, give an even surface to be stepped on. The pavers also protect the bitumen from damaging infrared and ultraviolet solar rays. The construction is similar to typical flat roof construction with a minor slope of 2° sign that leads to the edge of the roof where the roof drains and gutters were provided to drain rainwater to the main sewer. The 300 mm width and 50 mm height gutter is slotted at its edge to allow smooth run of rainwater to drain. Complete with PVC roof outlet, the gutter collects amount of water and drains it down the rainwater downpipe that is encased in the column. There are aluminium louvered wall on the flat roof to hide all the services equipments and water tanks from external sight. Provided series of crossed aluminium lattice beams above covering these equipments yet natural ventilated. The narrow corridor at the outer side of the aluminium louvered walls, which is used to allocate the condenser of the split air conditioning system, is covered by the metal decking roof. Can be observed that the water tanks and the cooling towers are set on the reinforced concrete floor slab between two main structural beams. This situation causes high bending moment for the floor slab. To solve this problem, the engineers put the additional cross beams on the floor slab to be the footers of the water tanks and cooling towers. The bitumen fillers are oxided under the direct sunlight for years and it causes gaps between concrete pavers become empty. These gaps are filled with water from pipes from water tanks and cooling towers and rain, which may affect the performance of the roofing system later on. The poor workmanship in constructing the minor slope also causes the rooftop being ponded. Leakage brought problems to the building. Even though many solutions had been suggested and some had been used to solve it, the building is still leaking. It causes problems such as prolific of fungus and stains at the ceiling. The intention to construct 1000 mm height parapet wall to hide the services is done well. The access to the services was given well thought by the designer, considering the mean to get to it and the width of spaces for people to move around to service it. To reduce the noise and vibration from the chill pumps and cooling towers, the rubber padding is used on the plinth beams that support them. This is the solution that the designers took and it is quite effective, since that the occupants inside the building do not feel frustrated with the noise from the roof. The UniAsia building has a very bold design concept and the intentions are successfully achieved in no question, but in the other aspects of the architectural design, especially on the roofing system, many problems may be occurred if we choose flat roofing system. To conclude the lesson, we should ask more, think more and observe more for better future architecture.